So in order to apply the equilibrium equations for a rigid body, we need to first create a simple model of our mechanical system. So in order to do that, we're going to draw a free body diagram. So the free body diagram of an engineering component will involve that we're going to isolate our rigid body from its surroundings. Once we have our rigid body isolated, we're going to draw all the internal and external forces that are being applied to our rigid body. Then we're going to apply our two equilibrium equations, which is our resultant force is equal to 0, and the resultant moment at any point must also be equal to 0. All right, and then once we have apply those two equilibriums, we'll be able to find any unknown forces or moments that are being applied to our system. So, uh, so in order to properly draw a free body diagram, we need to account for a few. We need to be able to account for a few things. So one of the things is that typically our rigid bodies are not just floating in space; they are supported by, in some manner, by some type of support. So support reactions, what they do is they to prevent our rigid bodies from uh, translation, which is linear motion, or rotation, which is rotary motion. All right. So the type of support reaction will change the type of so the type of support will change the type of force or moment that will be applied to the rigid body. All right. So the three most common types of support reactions that you'll see in many of your homework problems are going to be the roller support. All right. So the roller support would be if you had a rigid body. All right, here's a rigid body. All right, and underneath our rigid body, all right, we have a roller. All right, that makes contact with our rigid body. Okay, so this is our support. All right, now the rigid body, right, can do, so what we're interested in is how does the roller restrict the motion of our rigid body? So in this case, the rigid body would be allowed to translate in any of these directions. All right, it could also rotate about this point. All right, so we can translate in positive x and y, and it can translate also in negative x axis. It can rotate about the z-axis, right? So the only way it cannot move is about the negative y-axis, okay? So negative y is what's missing. All right, so since it cannot move about the negative y-axis, we can say that the roller support would prevent translation along that direction. So it would apply a force that would resist that motion. Okay, so this would be our supporting force. All right, so our second case would be is what's called is when you have a pin or a hinge that attaches to your rigid body. So in that case, so what this will look like is we'll have so our rigid body is this beam here. Right, and we have a pin that's going through the beam. All right, now that pin only allows the body to rotate. All right. All right, but the body can't translate at all. It can't move to the left, it can't move to the right, it can't move up, can't move down, but it can rotate about that pin. Okay, so because it prevents any translation, the pin will prevent, we can say that it would apply a force along the x-axis or a force along the y-axis. So we have two unknown forces in this case. All right. And then our last case would be for a fixed support. So if we had our rigid body is fixed to a wall, it could be like welded to the wall, it could be bolted to the wall, and what can happen in this case is that no matter how you pushed or pulled or tried to rotate this rigid body, it would not move. Therefore, we can say that for fixed case, it would apply a force along the x direction, it could apply a force along the y direction, and it could apply a moment about the z-axis. Okay, so there'd be three unknowns. Right, there's no translation or rotation for this fixed case. So we're going to, so there's a list that's been given to you in your handout, and this list explains many common types of support reactions in two-dimensional systems. It gives you it gives you the directions of the unknown forces in many cases. So I think in this case, these are all these have one unknown force. All right, and then on the next page, there's some that have two unknowns. And then there's one last one that's a single unknown. Okay, so, and then they show you some practical examples of these different types of reactions. I am going to post a video that will go into the different types of reactions for 2D systems if you want to know that in more detail. But you can always reference this table if you need to know what types of support reactions are available for different common types of supports that might see in your homework problems.